Good evening, everybody. This is Shane. I'm doing on 7th of April 2026, and let's do some coding, right? Okay, it is very sweaty over here. We are supposed to do some programming in operating systems today, so tomorrow we have an internal, right? Okay. So we were given like 4 experiments actually. Okay, let's do this. Okay, let's just write this. So that is fork system call, and the second one is cp command simulation. The third one is page translation, like oh my god, it's very sweaty. Logical to physical address, and the fourth one goes like FCFS scheduling algorithm. Okay, Control X. Okay, cat. Is it cat or touch? Right, it is cat. Okay, so let's do this. RM fork 1.c. Okay, and nano fork 1.c. Simulating fork command. Okay, it's not a command, it's fork system call. We will include that, and we will include this for the weight, I guess, and we will do this for the fork system call, and in PID is equals to fork. We are creating a child process now. If PID is equals to 0, print executing child process. Okay, you need to actually put a backslash n over here. Okay, so what shall execute? Printf the PID of the child process is %d, comma, backslash n. Get PID is actually a function that returns the process ID of the current process it is executing. And similarly, okay, it did not get terminated properly. The PID of the parent process is %d backslash n. Get PPID, that's get parent process ID actually. All right. So that is basically it in the child. Else wait for null. It is going to wait for the child process to terminate, and now right, executing parent process. Right. Print the PID of the parent process is %d backslash n get PID. These are just basic printf statements. That's it. Or you can also do this like replacing parent process with else command using exec else system call, something like that. I'm writing SS over here. Oh my god. execl, you can do it like bin ls, and the ls is a command, and since it takes variable arguments, it is null at the end. I'm sorry for the disturbance. Right, that's it. Control X, insert is void main. There is no need of writing return 0. gcc fork1.c, output file is going to be fork. You did not put a semicolon, instead you put a colon somewhere. Where did you put it, my guy? The last line. Precisely. So I have included the necessary library, right? Okay, it is syswait, not standard library. My bad. But still, it got compiled successfully. But let us be perfect, shall we? Hash include sys /wait.h and gcc fork1.c, output file is going to be fork1, and we will navigate. Okay, as you can see, these two numbers match out. That is exactly what we wanted, and the offset between these and this is 1. That is also desired. That is it. Okay, and it did not print it out because it did not, what do you call it? It is just in the buffer right now. Okay, I really love it. See, as you can see, this line did not get printed because it needs to be flushed out. Okay. Wait. Yep, see? And I forgot to put a backslash in, or else this would have come down. That is for the first experiment, people. And what is the second one? The second one is cp command simulation. cp.c, and let's see if we got any comments meanwhile. Okay, we did not get any. All right. So it is cp simulating cp command include stdio.h. You are just copying file. So do you need anything else? I don't think you need anything else. Right, man, you just need 2 files actually. Printf simulating cp command. Okay, and a file type. You will have a source pointer and you will have a destination pointer. src, you will open this, you will use this function fopen a.txt, comma, the mode is going to be read mode and destination is going to be and we are doing the opening the destination file. So we will just create an empty file b.txt and we will put it in the read mode as well. And now what shall we do? We will have character ch for the buffer, and we will have a character buffer. What next? You will use the functions fgetc, fgetCharacter, and fputCharacter. Right. So you can use this command while, since you do not know how many characters there are going to be, while ch is equals to fgetc from the source is not equals to the EOF, which means the end of file. Right. So now fputc, you will put the character and the destination. printf copied successfully \n flush standard out. I think that should be enough. This is a cp.c output file is cp segmentation called code dump. Wait, let me see. This is very common fault actually. So you're opening files. There are no files right now, but why did we get that segmentation fault actually? Okay. After like copying, you are supposed to close the files. F close src f close dest and let's do a .txt. This is the text to be copied. And let's do gcc output file is going to be cp. And you are also supposed to do this like nanob.txt hello. And let's run that cp copied successfully, okay? nanob.txt. Why is it still hello? F put C character in the destination. Okay. Let's ask ChatGPT what is wrong with this. It compiled, but we obviously still got a few problems. The code compiled, but we got a few problems. Wrong mode. Okay. If src is equals to null, source file not found. Okay. Int ch. Let's see. So why did you write in ch? Then what will you say? Okay. Destination is equals to null. Okay. So yeah, I thought of the same. Why are you opening both of them in the read mode? I actually like read the code somewhere. gcc output file cp. That's good. That's good actually. And we did like 2 programs now. And we will write them once again once we have completed it. Let's run this. Alright. Okay, I got this a.txt and b.txt. We did this cp and we did this fork, and we got our objectives clear. I'll just switch off the AC. It is already cold over here. And now what will you do? The third one is going to be FCFS. just need this, nothing else. And inside the main, simulating FCFS. Scheduling algorithm. We are simulating that right now. Enter the number of processes. Int P. Scan person landing ampersand P. Okay. And printf. Okay. You got the number of processes for int I is equal to 0 as 17 I plus plus printf. Enter the burst time of process presently, comma. Okay. And int bt of n. Okay, p, my bad. Enter the burst time of process 1 and scan of percentage, comma, ampersand bt of I. Okay. And now in wt of p, you are just allocating memory for calculating, and you will put the wait time of first process as 0 initially, and now for every process you will wt of I is equals to wt of I minus 1 plus bt of I. Okay, you calculated the wait time and print the execution of processes is as follows. For every process, print of process presently executes let's do one thing. Presently process presently executes with the wait time of presently. Right, that is I plus 1 comma I plus 1 and wt of I. Oh, to the number of process. Let's do this. Enter the burst time of process 1. That is, let's do 10, 20, 30 through 5. Okay, you just need some backslash and some formatting. Right, and you just put a slash and a backslash. The burst time is not what we are expecting, to be honest. Right. Somebody commented. I'm just doing some OS internal prep. Welcome to the stream and good evening. Sorry, Swapnil bro. So what is wrong? The wait time. Right. Okay, accessing wait time of -1. That is what I have thought. But you overrated incorrectly. Previous process burst times. So current process waits for all previous processes, not including its own burst time. Hey, this is what I have actually thought. Like I legit thought of it while reading the code. Burst time of -1, okay. And now CFS.c output is CFS FCFS. Let's do 5, 10, 20, 13, 4, and 5. What the? No. This is not at all intended behavior. What did it do? That is what I have done. Wait time of I-1 is wait time of I-1 plus burst time of I-1. That is what I did, right? No, like where did it go wrong? Enter the number of processes, okay. Enter the burst time of process percentage I plus 1 burst time of I W WTFP, okay, that was declared over. And okay, so you need to change the iterator from I is equal to 1 because the wait time for first process is already 0, and if I starts from 1, then if I starts from 0, then -1 will be accessed. Right, that is enough, I guess. Okay. Yep, this is intended behavior. 30, 60, 60, 69 it should be. No, 64 only. Because this 5 won't count, right? Okay. I think this length of output is sufficient. Okay, one of your messages got deleted, retracted. Okay, never seen what that is. And I don't know what. Okay. Wow. I don't know if you can see this. Like if you toggle on this, it changes the emoji. This is my first time actually seeing it, and this is cool. Yeah, I tried to. I mean, I got what you're trying to say. Yeah, These small things add up, man. And these small things really do add up. Anyways, now we are down to one more program, that is paging simulation. Okay, page.c. Let's ask ChatGPT about the paging thing that we have. I need to learn the minimum for page translation logical to physical address. You give the page table entries, then you ask for logical address, then you calculate page size and no, you ask page size, address and page size, and you calculate page number and offset, and you calculate frame number. And I have memorized the structure of writing code, but don't know what all of that is and how that works. We explain the main philosophy behind paging and translation. Right, mental model. Your program thinks it has continuous memory. RAM is fragmented, shared, and limited, so the OS lies in a good way. Hello, take clean continuous memory. It will scatter your data anywhere in the RAM. Okay. Logical memory is divided into pages. Okay, physical memory is divided into frames of same size. So the page size is equals to frame size. Okay. And logical address, page number, and offset. Okay. Address is 13, page size is 4. Okay, got it. Yeah, like every block is 4th of size. Okay, that makes a lot of sense. In every block, to exactly pinpoint that, you also need to know that offset, which is where the modulus operator comes into play. Page number to frame number. Okay. No fragmentation issues, easy swapping. TLB mass lookup. Let's write a basic program that demonstrates the page translation, like we write page table and ask for TLB and calculate the physical address frame number. So demonstrating the translation. Take number of okay. Let's see. So this is a page table of 50 size. Enter the number of pages. Enter frame number for each page. Okay, enter page size. Enter logical address. If page number is greater than or equal to n, invalid page number. Yes, this is the condition that I have written actually. Find frame number. Okay, so the page table of page number will be the frame number. Physical address, this is just the formula where frame number into page size plus offset. Okay, this makes sense. This actually makes a lot of sense. Okay, it's been 31 minutes. All right. So can we write this code? Okay. So it is very simple. You take the number of pages. Why do you take the number of pages? So you are constructing a page table. You need number of pages. You need a frame number for each page. Okay. You need the number of pages and the frame number for each page, and you need that page size. Okay, so now imagine this. Firstly, you are deciding how many blocks you need, and you are assigning a number which is essentially the frame number for each that page. And then what you are doing is you are allocating the size for each of the block, that is page size, and you are asking for a logical address, right? The address to find, that is a logical address. And finally you calculate the physical address. So you get that you calculate that page number and you calculate that offset, right? Calculate that page number. Wow, right. This is confusing, obviously, but still you are constructing a table. Firstly you need the number of pages, and you need the frame number for each page. You need the frame number for each page, and after that, what do you need? You need a page size, the actual size, and the logical address. From that, you calculate the offset and the page number. Didn't we write that page number before? Okay. Number of pages and page number are not the same thing. I feel like we are confusing over there. We wrote that page size and we will get that logical address, okay? And you will get that page number and then you will get the offset. You will print the page number and the offset, and if the page number is invalid, because that page number should lie within the n is number of pages. Yeah, and you will get that frame number of that corresponding page number from the page table. You will calculate the physical address. That is it. There is a lot of things going under the hood for this one. Yeah, I think we can do this. And frame number into page size by frame number into page size plus offset. It is as simple as that actually. Number of pages and the page table. We got the number of pages and okay. It feels like I'm having a lot of hair fall, and due to that reason, my precious keyboard is getting damaged, and I don't like that. So you made that page table, and now you will get that page size. Okay. You actually did not construct the page table yet. Printf enter the frame number for each page of the page table. Always end with an explanation. That really helps. Yep. Enter the frame number for each page of the page table for enter is equal to 0 and less than ni plus plus printf page number presently frame number question mark. Page number, okay. I plus 1. Scan presently, comma ampersand. You will get that page number. Page table, it's an iterator, that's it. And after you got the page table, what will you do? Alright, it's been like 40 minutes. I think we will complete it in like 10 more minutes. Can we? Yeah, I think we can. And then I will eat and I will call it a day. Also, we thought of doing FSD, right? So, where until did we go? We got that page frame number entries for each corresponding page in the page table, and you need the logical address, and you also need that page size. got that logical address, and you need to get the page number. Okay, as I have told, page number and number of pages are not the same. Okay, ALA by page size int of offset is equals to ALA mod page size if page number is greater than n, printf invalid logical address. That's right. Can you just write a return command over here? Okay. Now you got the page number and the offset. PA is page number times page size plus offset. Printf the physical address for the corresponding logical address is %pay. Yeah. Here. Can you do that? So the page size is somewhere around 25. Enter logical address. 25 times is 125. You can do something like 100. Really? So if you do the math, 100 okay, that is actually 4, 5, okay. Is the math even mathing? So for the 4 it is 5, right? 5 into 25 should be 125 if I'm not wrong. It's not coding. Okay, you fetch that corresponding frame number. So the frame number is going to be page paragraph page number frame number and page number. Okay, so it is 45 and the size of the page is 10, so it can hold. All right, so that is going to be 40 plus 5. 4 is holding for 2 and 2. Okay, so the frame number times 2 times 5 is 10. Right, 10 plus 5 is 15. That is solid. Now it is working out. So we have completed it successfully in 47 minutes. I will just try to write them once again. And I'm ending this stream, and thank you everybody for joining, and bye bye.